Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Louis Pilfold. I hope I said that correctly. As we said before, my French is not the best, and he is the creator of Gleam. Now, the reason, of course, I know him is because, as you said many times before, I still am in the Elixir community. And we had him on as a guest on the Elixir Mix podcast, and I thought talking with him about languages was super fascinating. And the fact that he's using Rust to compile his code, his Gleam code to run the Beam, which is the Erlang virtual machine, I think is super interesting. And so I'd love to have him, talk about that. But first, let's just give a quick self-introduction for yourself. So why don't you go ahead?
Hey, I'm Louis. Thanks for having me on the show. It's really cool to talk about Rust because I normally only really get to talk about the sort of Erlang side of things. And there's two big parts in this project, other than Gleam, Erlang and Rust. So yeah, I've been working on this programming language for maybe 4 or so years, and it is an attempt to bring some of the wonderful statically typed goodness that we have with languages like Rust to the Erlang virtual machine, where things are traditionally always very dynamic in nature. Which is great, but we also really like statically typed programming. And the first version of the compiler was in Erlang, but after a while I switched over to Rust, and it's been absolutely fantastic. It's been a real joy. Let's chat.
Yeah, so I would love to hear about maybe let's talk about the journey of that, because I think that could be super interesting. So you're first using Erlang as the compiler. So it just doesn't make sense to me, because Erlang is kind of a weird language because it's like both compiled but yet interpreted, and it does have this hot code reloading capability. So I just can't imagine a language like that, like compiling code. Like, isn't there like a YACC or YAC, as they call it? Is you using that, or can you talk about the early process?
Yeah. So the reason I picked Erlang originally is because it's really nice to have the compiler written in a language that's very familiar to the users. And I was thinking, hey, in future, it would be really great if we could get, these Gleam devs who probably know a little bit of Erlang, or they do know Erlang, and they've also learned Gleam, to be able to hack on the compiler. So that's really good. And, if I'm going to pick a language, the one that is native to the runtime makes a lot of sense. So, you look at the core of Clojure, it's written in Java. You look at the core of Elixir, it's written in Erlang. It makes a lot of sense. If you look at the Erlang compiler, it is also written in Erlang. So it makes a lot of sense to stick close to the runtime itself. And in future, because Gleam has really good interop with Erlang, we could start porting bits of the compiler over to Gleam and have a self-hosting compiler, which is really attractive to me. But
isn't that always like the test? Like, once it can compile itself, then you're in a good state. Sorry for interrupting. I was just thinking about that.
It feels like it feels like the moment you've really made it, doesn't it? My language is so good, it can implement itself. That's pretty cool. But then maybe you've written a language that's only good for implementing itself. It's not good for any useful things. And so it's quite good in a way that I can't start that project because it's very tempting. But actually there's more important things to do. Hey, we should probably get a really good build tool. Or hey, wouldn't it be nice if the documentation was as good as Rust's? Or we probably should have some more libraries, Because rewriting the compiler doesn't really help anyone other than enabling me to scratch my itch. But the original Erlang version of the compiler quite quickly became quite difficult to work in. And I don't necessarily think this is... I'm not saying that Erlang's a bad language. I love Erlang, and it's really good. But it's just built for a different set of problems. It's made for making network services that are massively parallel or distributed and want to be super fault tolerant and do loads of things at once, and that fundamentally just isn't what a compiler does. A compiler is about manipulating this tree structure and doing clever introspection things, and it's almost entirely single threaded. So a lot of those advantages for Erlang weren't there, but then I found myself really missing lots and lots of the advantages of a language like Rust or Haskell or something like that. I really wanted to be able to add another variant to the enum that was my syntax tree, and it say, hey, look, you need to update this clause, and you need to update that pattern match, and you need to do all these different things in order to update it. And I was doing that manually because it's a dynamic language. And that just became really challenging. And at some point, I realized that I needed to do big refactoring because I'd sort of painted myself into a corner, as it were. And I just didn't feel confident that I was going to be able to do the refactoring, or at least not in any timely sense. And it was getting quite stressful. And so I sort of sat down and thought, do I really want to be butting up against this problem all the time? If there's a better tool that I could employ here that would make all these problems go away, perhaps it's worth taking the time to make a version 2 of the compiler and have a go. So I started a little experiments with Rust to see what it would be like. And it just went so incredibly well. It was so much easier to move around the code base and make changes for this particular kind of problem. And because it was in Rust, it was like so much faster. So just kept going with that and never looked back, really. Now we're 100% in Rust.
But there was no like other choices or like trial and error till you finally got to Rust. It was just, okay, let's just try Rust, and that was it.
So I really love languages, and I'm really a fan of the sort of ML style languages. So I've written a lot of Haskell and OCaml and that sort of thing. And I knew I wanted something that was statically typed. I think I wanted something that compiled to native code, because if I'm already asking the users to install a virtual machine, asking them to install a second virtual machine because I've written the compiler in Scala, for example, it's just a no-go, really. Like the tool chain just becomes far too unmanageable. So I wanted them to say, hey, install the Erlang virtual machine, and like here's the single file that is the compiler, and off you go. So that kind of narrowed it down to Rust, OCaml, and Haskell. And they're all really good languages and I like them a lot, but I just sort of had to think, which of these am I going to want to, if I was going to be stuck with one of these for a long period of time, which one would I want to be stuck with? And it was a really tricky decision, actually. But there's a few things that, really stood out about Rust for me. One of them was just how good the tooling and documentation is in Rust. OCaml and Haskell they're pretty good tooling, but Rust is just absolutely incredible by comparison. I've been dabbling in Rust for quite a few years before that, and I'd never had a single problem with, dependencies not installing, or, I couldn't compile this random open source project or that sort of thing. While in OCaml and Haskell, that would be a really frequent occurrence. And then, if you're going to spend 4 years writing one language that, so you're probably going to get pretty good at it. Which one of those is going to align best with your future goals? And I wouldn't mind being really good at Rust, and I wouldn't mind working in some Rust places, because there's all sorts of things that you can do in Rust that you can't do with other languages. And a lot of the things that I could do with Haskell or I could do with OCaml, I could kind of already do as in other languages that I already knew. So two specific examples are, I'm really interested in music technology and audio and synthesizers and stuff. And with Rust, you can do audio DSP because there's no garbage collection. You can write code that, makes bleeps and bloops. So that's really exciting to me. That's really cool. And I always feel like one day I'm going to make my own, synthesizer or something. So now I've also gained that other skill. So there's a mixture of benefits for the users. This nice single binary thing is really fast, and the benefits for me in that I can, do some more things I couldn't do before.
So what I wanted to ask was like tooling, right? I always hear this word tooling, but to me, tooling, like I'm thinking about the Erlang observer, right? To me, that's a tool. I don't see anything similar, at least not quite yet. There's something for Tokyo that's coming out, like a Tokyo inspector, which is kind of cool. But like when you say tooling, like what are we talking about for tooling? Like I think the only thing I could think of would be Cargo. Yeah,
Cargo is the big thing, really. There's one tool which, it is the de facto thing, and it comes with the language, and it can install dependencies really easily, and it's got a really simple workflow. I can download any Rust project off GitHub pretty much, and I can run Cargo test and feel confident it's going to work. Like, that's really great. While you don't really have the same experience at the moment with Erlang or OCaml or Haskell or even Gleam, it's not really a given which tool is going to be used. And dependencies can be a bit tricky. Maybe you've got to download them in different ways, and there may be implicit dependencies that are meant to be handled by the operating system or something like that. And it just becomes a lot more challenging to go from, there's a lot more friction involved in going from being interested in a project to being able to run it. And the onboarding experience is really important to me. Something we're focusing quite a lot in Gleam is how can we make it as easy as possible to learn the language and learn the tooling and get started. And the other side is that sometimes it's just a bit more awkward. On a day-to-day basis, it's like very little things. Like the user experience is so nice with Cargo. It's just a little bit more fun to program. You just do a little bit less wrangling with the command line in order to get things done, which is just lovely. I suppose one caveat is that it ends up it's comparatively slow. Like if I was using a Camel, it'd be much faster, but I kind of solved the problem by buying a faster computer, and then that problem went away.
You remind me of the old way of programming. Like, don't worry about writing faster. Just wait 2 years; it'd be twice as fast, or 5 times as fast. Right?
That's pretty much what Joe did with early Erlang. They said it was too slow. Said, "Okay, wait 4 years; it'll be fast enough." Okay.
No, I was just thinking like. So I did Rust for a project of mine with Flutter, right? So everybody had Flutter installed. Everybody had C compilers installed because that's just what you get when you have Xcode installed because we're mostly working with Mac. But not everybody would have Rust installed, right? So you are asking for them to install one more thing if they are going to work on the Rust compiler. Although it is easy to install. This one I definitely will say was like you just do Rust up and you're nearly done. Like even on Windows, it just kind of works. Like the part. But you're still like asking for something, right? Like nearly every PC, whether Linux, whatever, except for maybe Windows, they all have C compilers. But having a Rust compiler is definitely an extra step that they have to kind of venture out on their own.
Yeah. And that was the argument for starting with Erlang, really. If they're going to be a Gleam user, they have to have the Erlang virtual machine installed. So, if that's the only thing we depend upon for compiler development, that's good. That means every user can be a compiler developer with no extra effort. But it turned out that would have been great, but the cost was a little bit too great for how much benefit we got. And Rust is a pretty good experience. The C argument's actually pretty strong. People almost always have a C compiler installed. Problem is, I'm just a very bad C developer. I moved to Rust because I wanted it to be easier to write this compiler than it was in Erlang. And I'm not really convinced, at least with how good I am at C, that it would have been easier. I probably would have been facing not the same problems, but I would have been facing a similar set of problems if I was working in Erlang.
I think another thing to talk about too, let's kind of talk a little bit more about like Erlang and how it relates to like why you created Gleam, right? Because we're basically, I don't know, how would you even say that? I mean, you're using, it's kind of funny because you're using kind of a newer language to solve a problem of a even newer language than that, right? Like, what's the point, right? Why not just do everything in Rust? Because it seems like you're pretty happy with that.
Yeah, so Gleam really comes from myself liking lots of different languages, but always being a little bit frustrated when I'm writing any of them because there's always something that's a little bit easier. Oh, if I was writing Rust right now, this thing would be easier. Well, like with the compiler, I was saying, oh, I'm writing Erlang. I really like Erlang, but if I was writing Rust, managing the syntax tree would be much easier. And there's times where I'm writing some Rust code and I'm thinking, oh gosh, the ownership system is really kicking my butt here. If I was writing OCaml, I could just do this, or if I was writing Erlang, I could just do this. And there's always some middle ground, some nirvana that just isn't quite there. And I'm not going to pretend for a second that Gleam is going to solve all problems. When I'm using Gleam, I'm going to be wishing I'm writing Rust, or I'm going to be wishing I'm writing Erlang. But it's going to be a combination of features that I frequently want together because I really love the Erlang way of programming, and the Erlang virtual machine I think is really good with its sort of fault-tolerant properties and its actor-based concurrency system and its very simple functional programming model. But also a lot of those static guarantees that you get in languages like Rust and OCaml and stuff like that. And one of the reasons why Rust is probably one of the strongest languages I know. Like, I would like to recommend Rust for pretty much everything, but it comes with a huge caveat, and that is that I think compared to a lot of languages, it's just very challenging to get productive with Rust. And I don't think that's because Rust is doing anything wrong. I think it's just because Rust is tackling a much more challenging problem than a lot of languages are. They're trying to tackle the same problem that C++ and C are tackling. And I think compared to them, it's actually easier to learn. but it's still much harder than learning a language like Go or Erlang. And so I really want to have some of those wonderful things of Rust, but in the problem space but to be in a similar space to Go and Elm, where we can be really easy to learn. Like I would like to see Gleam be a good candidate for somebody's first programming language, particularly people who aren't from a very technical background, where something like Rust could be quite overwhelming.
Yeah, I kind of gave you a little bit of a loaded question, right? It's quite a few different things at once, but I'm going to kind of go back to like Erlang, right? And like, why is it that you wanted to make something that you kind of basically already love even better, right? And what is the changes that you made, and why is that difficult? Because this is actually, I may be giving up too much, but like one of the things is like, this is something that Erlang also wanted to have, right? They wanted to have this kind of some of the features that Gleam has, but they never implemented it.
Yeah, there's been there's this sort of meme, I suppose, this thing that's been said for a long time in the Erlang community, that it's not possible to apply static types to the Erlang model of their actor framework called OTP. You can't apply types to it. And for many years, I just sort of took that as given, because lots of people keep saying this. But then, the more I got interested in attempting this, and the more I, would go on walks and think hard about, how these things fit together, the more I sort of believed that is sort of true, but that, there's a lot of caveats there. And in the general case, it isn't true at all. You can definitely apply types to the actor model that Erlang uses. And you can definitely do so in a way that is, not just practical, but actually really useful. The problem is just that you can't do it in a way that is perfectly backwards compatible. You've got to choose some things to exclude and some things to break. So an example would be the Gleam has an implementation of OTP, the actor framework, that is perfectly compatible with the Erlang one. But it just has very, very slightly different APIs. So you can't just take your Erlang code and effectively copy it into a Gleam file and it'll work exactly the same. You've got to slightly reshape the APIs. Like that's not a huge problem. But there's things that are more complicated. Like Erlang has the ability to, inside your production system, load new versions of the code, so you can upgrade your production cluster without taking any of the nodes out. Which in the modern sort of cloud environment may not be super relevant. But if you think that Erlang was built for a bygone age in the 80s, where computers lived on top of telegraph masts and stuff like that, you can't turn the computer off. There's only one of them. It must keep working. You needed a way to upgrade the code, and so now you've got your code base is a mutable thing, which is if you're doing typing, that's super challenging. And I think with further research, we could actually start to get some solutions for these things, but especially at the time, when these things were first decided, like the technology just wasn't there. So yeah, people say you can't do it, but I think you really can. And I'm hoping that with Gleam, we've shown that you can, and more people will start to get excited and try and bring more static analysis to the Erlang world.
I think we're still not kind of giving enough. I'm afraid that like you and I have too much insider knowledge about Erlang and how it all works that we should probably talk more about like, what is Erlang? What makes it special? Yes. Why would people ever want to use it? And then talk about like, why is it that adding a type system is difficult? And also like, why is it that there was never a type system, right? And I think the main point about that one is you don't know what's going to happen. That's kind of the Erlang philosophy, right? It's like anything could happen any moment. That's what comes to my mind.
So yeah, good. That's a great point. But let's roll back slightly and talk about what's the point of making a new language on Erlang at all? And like so, the extension of that is like why should anyone be interested in Erlang? And I think that's just because Erlang, almost by accident, is a really powerful and very interesting language for the modern age. So Erlang, unlike most functional programming languages, Erlang doesn't come from academia. Erlang comes from a company having a very real business need and them needing to solve it in an efficient way. And so this was Ericsson, the telephone company in the 1980s, were writing the firmware for their telephone switches in C. And they were finding that actually it was just a lot of work to write these very strange bits of software that needed to be super concurrent and low latency and always talking on the network and want to be tolerant to faults. If something goes wrong, the system shouldn't go down. Like these really strange requirements. And they're finding it was really hard in C. So, but we know now that these are super commonplace. Almost everything needs to be a networked, low latency, super concurrent thing. But at the time, it was really strange. So there wasn't really much in the way of resources they could use, and they started a little research project into what would the ideal programming environment be for writing this firmware, so they could start doing it much quicker because they're spending a lot of money on building this stuff. And they started originally by trying to make a language. They started originally by trying to make a library for Prolog. They wanted to make a sort of concurrency library for Prolog, and they kept exploring these ideas, and they sort of invented the actor pattern in isolation. They didn't know it was the actor pattern, but they just had this great idea of these isolated things concurrently sent messages to each other. And it sort of grew and grew until it stopped being a library for Prolog and started being a language in itself. And they tackled loads of problems that we only today are really starting to face into. So the idea that everything is inside an actor, and all these actors are isolated. So you write code that only does one thing in a single threaded fashion. But then you have, if you need to do 1,000 of those things at the same time, you have 1,000 actors, and make it really easy to like spin up new things. So having lightweight fibers, which everything seems to have these days, is the thing they're doing from the start. And so they solved the concurrency issue, and then they made it transparently split across multiple threads. So they solved parallelism, and these telephone switches needed to talk to each other. So they ended up solving distributed computing as well. So sending a message on an actor on the same machine is exactly the same as sending a message to an actor on another machine. And they needed to be able to deal with the fact that these computers are often stuck on the side of a building with a load of wires coming out of it, or up a telegraph pole or something like that, and they could be struck by lightning at any second and just stop working. So they needed to handle errors in a way that you can't really solve with static analysis. Static analysis works on the idea that your code isn't going to change and the rules are not going to be bent, but there's nothing stopping a bit of cosmic radiation from striking your hard drive and flipping some bits from 0 to 1 and 1 to 0, and suddenly everything goes out the window. So they needed a way to be able to survive those things. And so the idea that things can just vanish or stop working or misbehave is built into the system itself. It's all fantastically impressive stuff. And weirdly, the whole world has come around to needing solutions for the problems that they've been facing for a long time. And I think there's a lot to learn in Erlang. And I think lots of languages are learning from Erlang, but I think there's still a lot of value in the original thing. So we should make use of it more often, I think.
Says the guy who wants to take another programming language on the same VM, right? Kind of replace it a little bit.
Because I think Erlang, when we talk about Erlang, we kind of talk about two things. We talk about the language of Erlang, which is a nice little functional language that is very simple, but there isn't really much to it really. But then we talk about Erlang as in like the programming model, and by extension the virtual machine that implements it, because it's actually kind of difficult to port the Erlang model to runtimes that are not intended for it. Because certain features like isolation between different actors at the memory level, and the ability to be aware, to be notified when an actor that you're interested in has crashed or has gone down, or the ability to group actors together in such a way so that if that actor fails, then all these other actors should fail because they depend upon it. Building these relationships, all these things you can simulate them inside other languages and other runtimes, but it becomes incredibly difficult to get right because almost every other runtime has the idea, well, like if something crashes, well, everything just crashes. There's a big problem. Everything gets poisoned. While this runtime is built in such a fashion, it's built like a ship. It has bulkheads. If the side of the hull gets pierced, that compartment of the ship floods with water, but the rest of them are okay. And it becomes quite error prone to try and replicate that in other languages.
Yeah, and that definitely makes sense too. And I think that kind of I think I kind of mentioned this before, is I think having this idea of like, how can you type check something which you don't know what's going to happen, right? You really have no idea. You can only do it dynamically, possibly like similar to, I think, a lot of languages where you can say at runtime, what is this thing? What type is it? That's probably the best you can do, rather than like, oh, this is going to be a string or whatever.
Yeah. So I think and this is this is one of the tensions that come up when people talk about typing and Erlang. People ask, why should we do all this static analysis to try and identify errors because we have this error handling story? Like, what's the actual reason to have both of these things? Isn't this redundancy? And I think that no, it's not redundant actually, because I think you can separate things. I think you can categorize errors into at least two categories. The first one would be, say, like program errors. This function is meant to take a list, and I've accidentally given it a string. Oh no, it crashes or does something. That's not something that we ever want to say. Well, Erlang's really good because it can, if you do that, and when you go to production, it will only break slightly. It's like, yeah, well, in Rust, it would never happen ever. Surely that's good. We want to eradicate those kind of errors, the ones where it's just like, oh, someone made a little mistake. We can make all those go away. But then the kind of errors that truly are exceptional, like hardware failure or something outside of the nice pure boundary of your code changes, and goes wrong in a catastrophic fashion. And you can never ever handle those things statically because the universe is unknown and entropy is too powerful. There's nothing we can do about it. We can use static analysis to try and help us with that, but fundamentally we can't beat it. So we really want to have an error handling story for that. So if you split your errors up into expected things that happen within your domain, we would like to be able to handle these in a sort of local and static way. And then things that are truly exceptional, either because it is something really quite out there, like an act of God, the machine catches on fire, or maybe you're a startup or you're prototyping and you want to move a bit faster. Say, okay, well, I think in theory this API can return this thing, but in practice for us, it should always return this other thing. So I'm going to statically assert. I'm going to assert that this API always returns a 200 code or something like that. And if something goes wrong here, I'm just going to, well, that's outside of the scope for what we're doing at the moment. And I'm going to fall back to the fault tolerant properties of Erlang. So that's really nice. You can divide the domain into two parts. And then when something does go wrong, you know that it's not going to be something that's just like a little hiccup. It's something where you've deliberately said, this is outside of our domain. This is exceptional.
Okay, so you're saying is that kind of like the way that Gleam works? Is it kind of runs off of that part where it's saying that this is exceptional and so this is kind of like not part of the type system, or how does this actually work?
So in Gleam, it generally works by, we try and use the type system to verify everything, but there are some places in which you can tell the type system. Well, there are places in which you can assert that something is. So the way that it works in Gleam is that we try and use static analysis and the type system to analyze everything. So you get the same sort of thing in Rust, where it says like, oh, this can return an error. You must handle that in some fashion. But we also have, much in the same way that Rust has unwrap and panic and expect, we have the assert keyword. So you can say assert and then a pattern and then give it a value. So assert that this is the OK variant of the result enum you get back. And then if that isn't the case, it crashes. And at that point, because it's all running in these actors, only the actor has crashed. And then you fall back to the Erlang non-local way of handling errors with Erlang supervision trees and restarts and incremental state shedding, all this sort of stuff. But the important thing is that there's a really explicit place where you have said, okay, here's where I check to make sure this works. And if this doesn't work, then it crashes and you only look in that place. And the other thing is, if you look at a piece of code and ask, if you look at a piece of code, it could be Rust code, it could be anything. Which lines of these can throw an exception? Well, the answer is all of them, because you can always have an out of memory error. You can always have some hard drive corruption. You can always have memory corruption. Anything could possibly crash at any point in time. There's no way to handle that with static analysis. So that's another situation in which we would use the non-local error handling, the fault tolerance of Erlang.
Okay, that makes sense. All right. So do you think that people, or how do I say this? Do you think that the Erlang community should take a look at Gleam and maybe start to implement some of those features back into Erlang or something?
I think it would be really great if Erlang could get some of the static analysis that you find in Gleam and Rust and TypeScript and other languages. But the real challenge is doing it in a way that allows you to use all the existing Erlang code you've got in the world. So the reason why Gleam is not a type checker for Elixir or a type checker for Erlang is, well, I wanted the language to have a few other extra different things. But if you're just looking at the type system, the reason is that it's just it's a very different challenge applying types to an existing language. And I think if you just take the Gleam style type system, which is sort of OCaml Haskell style thing, and apply it on top of an existing language, it's just so strict and so harsh. It's very difficult for people to upgrade from the untyped Erlang to this new future typed Erlang. So I think you really need to design the type system with an adoption strategy in mind. And this is something we've historically really struggled with, but over the last few years, there's been a bunch of projects that have done this really well. And I think the big one is TypeScript. TypeScript's done an absolutely amazing job of making it so you can apply types to your JavaScript code base in an incremental way. And I think someone could take a lot of the research that's been done in the TypeScript project and apply it to Erlang quite successfully. There's two main problems here. One of them is that when using TypeScript, because you can sort of choose how much safety you want, you never truly get the same experience as you do with Rust or you do with Gleam. You always have to do a little bit of extra work to make sure things are tight and strict, and it just becomes a little bit more awkward. The other thing is that it's just a lot more work to implement a type system like in TypeScript than it is to implement one that, similar to in Gleam or Elm or OCaml. It's much, much more complicated. And I think if I started trying to implement a sort of TypeScript-like thing on top of Erlang, however many years ago I started doing this, I think I would still be working on it because it's just so much of a project. It really needs to come from a Microsoft or a Google or someone else, I think. And there was actually an attempt at this recently, a year or two ago. WhatsApp started a project to add gradual typing to Erlang, and I forget exactly how long it was going on for. I think maybe they did like somewhere between half a year and a year, and then they decided to pivot to, instead of working on adding a type system, they decided they were going to just focus on improving the tooling and improving the runtime and improving the language in other ways, because they were finding it was such a. I might be speculating slightly here because I wasn't involved in the project, although I did talk to them a bunch at the beginning, so I'm not 100% sure. It's not from the horse's mouth why the project stopped, but the gist I got was that they were finding it was so much work to add this type checker in the way that they would enable them to migrate their very large Erlang code base over, that they weren't getting the value back, even with the huge resources that they, comparatively huge resources that they had at hand for this sort of thing. So for what I wanted, it made a lot more sense for me to make a new language. But I really do hope someone tackles the same thing for Erlang in future.
I'm kind of curious if it's possible to somehow hook in Dialyzer to maybe give you some hints and start, adding some types here and there. But I don't know. I don't know much about Dialyzer, but maybe you can give some feedback about that. And also kind of maybe first a quick intro about what is Dialyzer, because I don't think, like I said, anybody in our audience knows.
So Dialyzer is a really really unusual type checker for Erlang that it's there and exists, and it's actually a really impressive piece of engineering, but lots of people don't seem to use it, or it is used, but people don't seem to use it quite as much as a development tool as, say, they do the Rust type checker. It doesn't tell you as much information. Like, you can make mistakes and it doesn't tell you about them. And the reason for that is that it was trying to solve the problem that TypeScript was trying to solve, in how do we add types to existing large code bases? But this was before gradual typing was invented. So this uses a technique called success types. And I I don't understand well enough and I don't have enough time to sort of explain how they work, but the sort of the general principle behind them is that they will only emit a warning or an error if they are 100% sure that there is an error. Which is super different to how almost every other type system works, where, so they have no false positives, while most type systems have a no false negatives. Like if it looks like it could result in an error, we're going to tell you about it, because it's better to catch all of the errors and also exclude a few things that, might not be errors, but I can't tell. So for example, I know this list is not empty because inside the function I put a value into it. Oh, but I can't tell that from the type system. So popping something out of it is safe, but the type system won't let me. Okay. In Dialyzer, they're like, oh, well, it could have something in it, so that's fine. We'll just let you do that. But it's only if it like 100% knows that there's a problem, it will tell you about it, which just results in a very different experience, and one that I personally got quite frustrated with. I really tried to make it useful for me, but it's very slow to run and it doesn't give you much information. So I just stopped using it in the end. I prefer to treat Erlang as a completely dynamic language rather than try and use a type checker.
I'm just curious, do you think that Dialyzer could actually help to kind of hint at some types or something? Or maybe not. It sounds like it possibly couldn't, because it's like you're saying, like you have to declare that this is a certain type and then it would have to check it, right?
So there are some cool things about Dialyzer. Like it doesn't need any annotations in order to be able to figure things out. It has a very deep understanding of the language. I think the problems are more, it's just very conservative in terms of what it warns about, and it's very, very slow, and so it will skip corners, which result in it being less accurate in order to avoid there being too much of a performance slowdown. But it can be useful in lots of ways. Like actually, it can still be quite good for driving editor integrations. So you can sort of like hover over functions and see what types are, because it can work those things out. It's just not as good for detecting inconsistencies as I'd like to do. But there are lots of good uses for it. And I'm a bit extreme. I got a bit frustrated with it, but lots of people do use it and find it quite handy. It just ends up being a different kind of tool than a type system in Rust would be. And I was really hungering for something like that, and that probably kind of comparing it to what I use it with the Rust type system for probably painted it in a bad light. But if I looked at it as a different kind of tool, I probably would have quite liked it, I think.
I want to go back to about how the compiler works, right? So in your process of creating the Gleam compiler in Rust, was there some yak shaving involved? Because, I mean, I don't think many people are I'm guessing it probably compiles to core Erlang, or does it compile to something else, actual bytecode, or there's some stuff in there I think that could be useful for other people. I don't know if it was something that you're piggybacking on, or you just kind of wrote everything from scratch and didn't separate it out into different crates.
So the first version of the Gleam compiler, which was written in Erlang, takes in Gleam source code and parses it and turns it into what's called core Erlang, which is an intermediate representation of the Erlang compiler. And it's sort of semi-recommended that it's a compiler target as well. So there's quite a few other languages that run on the Erlang virtual machine that target it. It's relatively easily to target it from Erlang, because there's a module which is responsible for building this intermediate representation, which you can use in your code. It's kind of tricky to use from outside of Erlang, because you've got to either know the binary format, or you compile it to like the text representation of it, and then you've got to like find some unusual APIs in order to ingest those, and none of the existing build tools will work with them. So when I moved to Rust, I made the decision to compile to Erlang source code, and then I could just dump that straight into the Erlang compiler or any Erlang build tool, and it will just work the old-fashioned way. And it's also had a bunch of nice advantages for development, because it's much easier for people to look at the tests, for example, and say, oh, look, here's some Gleam code, and it compiles into this Erlang code. That's really cool. Well, if it's, oh, here's some Gleam code, and it compiles into some very alien-looking compiler IR, it's like, oh, what is this? It became a much easier... In the way that it became more difficult for people to contribute because they have to learn Rust, it became easier for them to contribute because like the cognitive load of the compiler, and particularly the tests, was lowered a whole bunch. And there were some other nice advantages, like we can just generate a bunch of Erlang and then ship that. Actually, people may not necessarily need to have Gleam installed on their system in order to use a library written in Gleam, because it just becomes Erlang later. And we really focus on making it so that Gleam compiles to like very normal Erlang code, so you can have quite a nice interop.
So basically, literally, like you're just compiling from one language to another, right? It's almost like a coffee script, almost.
Yeah, it's. I think some people call it a transpiler, but I find the distinction between these things kind of silly, because the old version of the Gleam compiler compiled to this core Erlang, but actually there's not really much difference between core Erlang and Erlang. It's just, rather than writing this code using this textual syntax, I'm compiling this code into this tree data structure that almost maps exactly onto the syntax of the language. And there's other language, like Elixir is a good example. Elixir compiles. I think most people don't know this. It doesn't compile to Erlang bytecode. It compiles to the abstract syntax tree of Erlang. So if you just pass some Erlang and then you compile some Elixir that did the same thing, you'd have almost exactly the same data structure. So it doesn't really do anything different. So yeah, and it's quite nice because one of the problems with these compiler intermediate representations is that some of them are sort of public APIs, but some of them are not, and you can get break and changes between major releases, and it can all be a bit difficult, and it's almost always very badly documented. While the source code of the language, fantastically well documented, it definitely can't change because all the users are using it, and you can just, it's really easy to understand. So there's, I think there's probably a lot of mileage in targeting source code rather than intermediate representations, but people don't really do it for some reason. It's super portable as well, or work everywhere.
Seems kind of like a really an extra step in terms of like, transpiling from Gleam to Erlang, and then again compiling from Erlang to whatever the bytecode is, right?
Mm-hmm. Yeah, there is definitely like some cost because you need to run the parser again, but then depending on exactly what the toolchain setup is, you might need to do some parsing for the serialized format of the intermediate representation. So it's really hard to avoid these overheads anyway. If we were still running inside the Erlang virtual machine, we could definitely skip some of it because we could just pass like the Erlang values directly into the compiler. But we definitely don't want to dodge taking advantage of the Erlang compiler. It's a very it's a well-tested, well-written, quite well-optimized compiler. If I were to go directly to Erlang bytecode, I would have to re-implement a lot of the optimizations that they have inside their compiler, which would, I don't think that benefits everyone. We really want all of the languages on the Erlang virtual machine to take full advantage of the compiler and the runtime that's there.
I do want to ask one more question, right? You do like Erlang a lot, so why don't just now you know what Gleam to Erlang would produce? I mean, why not just write Erlang the way that should be done so that you have that type checking?
Well, the thing about the Erlang that Gleam produces is that it's very simple, and it doesn't actually do a lot of the dynamic type checks that I would probably do if I was writing Erlang. When I'm writing Erlang, I like to be quite, I think the word is offensive programming, as in the opposite of defensive programming. I check that everything is the way it should be, and I crash if it shouldn't be. I write loads of assertions all over the place. And that's because I don't have a good way of statically verifying these things are correct. So I want to dynamically verify all these things are correct. While if you look at the Erlang that Gleam outputs, it doesn't have any of these things. In fact, you could say it's very trusting because it just sort of accepts values and passes it on. And the reason for that is Gleam tries to lift as much of this stuff out of the runtime as possible and do it all statically. So like if I have statically inferred that this is a function that only accepts strings, for example, cool, I never have to check inside the function that this is a string. Well, I may have to do that if I was writing Erlang. So if you started writing Erlang in the style of, in the style that the Gleam compiler wrote, even though it looks very human, you might end up with some mysterious bugs unless you get everything perfect, which it could be quite tricky.
Okay. That makes sense. Is there anything coming up on the on some milestones for next version of Gleam?
Yeah, I've been really looking forward to the next version of Gleam because it's one where I copy some of my favorite things from Rust. I so one of the things that's been a bit of a sort of a slight pain point for Gleam for a long time is that we're currently using the Erlang build tool, and it's a pretty good build tool, but it's made for a different language, and when people join our Discord and say, "Hey, I've tried to start a Gleam project, and this didn't work or that didn't work." A lot of the time is just that they were a little bit surprised by the API of the build tool, or what set of commands you have to run. And I think that's fairly normal for people coming to a new language, not really knowing how to get the project set up and run the code and install dependencies and all that sort of stuff. But then I look at Rust and I just say, wow, you install cargo and you say cargo build or cargo test, and it just does everything for you. And I really want to copy that experience. So I've been very slowly working on a build tool, and I'm hoping with the next version I will have the biggest piece of the puzzle in there, which is installing of dependencies. And then I think this first version of the tool will be ready to release. And it's really, it's funny you mentioned you saying you like Elixir and Dart and Rust, because those three languages are probably the ones I've been looking at most for like how I should build this thing. So Cargo's got a really lovely user interface and is very easy to understand, and so does Mix. Mix is another big inspiration. Dart has a really amazing way of resolving dependencies. It's got in the new I believe it's from Dart, the new pubgrub algorithm for working out which versions you should be using is just absolutely fantastic. And so I'm hoping to leverage that in Gleam, and yeah, stand on the shoulders of giants, like have a really good experience because Rust and Elixir and Dart have shown how it should be done.
Well, I'm glad that finally somebody's telling me I'm choosing something that's good, because usually I get a lot of like, well, I have to understand, like out here, it's like if you don't do Java or C or JavaScript, then basically, you're doing everything wrong, is what I'm told all the time.
Why use this Gleam thing? What's the point of it? Eh? Should you stick with C? Why use Dart? But there's loads of really good stuff in Dart and Rust, and I hope to. I like to think that Gleam hasn't invented anything. It definitely hasn't invented anything, and it's not doing anything novel. It's just trying to be a grab bag of all the highlights of lots of different languages, hopefully tastefully smashed together. So there's loads of great stuff to do with tooling and dependencies and stuff in Dart that I'm wholeheartedly stealing.
But let's kind of go back to like Rust, right? Now that you mention it, Rust isn't really doing anything cutting edge necessarily. I mean, if you compare it with C, sure, but from what I understand, like this whole entire idea of the borrow checker and all that is like kind of a little bit of an older idea. It's like 20 years ago or 30 years ago. This kind of technology or this kind of thinking or method, it's not like brand spanking new, but the fact that, I guess that they're using it now is just really what makes it look like it's really sparkling, or am I wrong in that thinking?
I think you're right, but I think one way in which Rust is still quite pioneering is that they're the first, as far as I'm aware, they're the first popular language that incorporated it, or maybe one of just the first languages full stop that incorporated it, which is really cool. They've taken something which is has traditionally been sort of research. It existed in some paper somewhere, maybe on a few PhDs computers, and they've made something really practical and really useful for it, and that's super awesome and super impressive. And I think one of the reasons why Rust is having the tremendous success that it is. While I'm trying to copy from I'm trying to copy things from established languages, mostly trying to copy things from languages. I know that the type system works really well in Rust, and I know it works really well in Elm, and I know that the concurrency model works really well in Erlang, and I know the failure handling system works really well in Erlang, and I know the dependency management works really well in Dart. Like, how can we bring all these things together? Like, not just proven in theoretical ways, but really proven in in industry. And how can we like build a tasteful mishmash of all these things?
I would love to kind of talk about, like, we've been saying a lot of good things about Rust, right? This is a Rust podcast, but I want to hear, like, what has been like the not so good parts about using Rust as a compiler? Sorry, transpiler, right? Let me get that correct.
I quite like the compiler. I think they're both the same thing, really. I'm not sure it makes any difference. But the pain points of Rust, it definitely has taken me a lot longer to get productive with Rust than it has with other languages, which results in a lot of technical debt in some ways. Like people are always learning as they sink more time into something, and there's probably a whole bunch of things inside the Gleam compiler which I probably wouldn't do the same way if I was doing it again. Now, the good thing about this is that Rust makes it very easy to refactor, so I've been able to strip a lot of those things out over time. But I think I would have made fewer hiccups if I was working in a language that didn't have so much of a tough onboarding ramp. And it extends to more than just me. So this problem is solved for me by I've written a lot of Rust over the last few years because this whole thing is written in Rust. But then if somebody is an Erlang program, they want to come to Gleam and they go, oh, I'm interested in compilers, I want to have a go. It's a lot more challenging for them. Sometimes I get people say they want to pick up an issue from the issue tracker, and then they get started and they never come back to me. And I think that's because quite often that's because they find it quite challenging, more challenging than they would do if it is written in a language that is a bit easier in some fashions. Or I get people open fairly embarrassed pull requests where they say, oh, I got really stuck. I couldn't work out how to make the borrow checker do this thing for me. That is a shame. You do lose out in some participation in that fashion. And the other thing is that I was running I had a really nice light ultrabook that I really liked when I started this project, and running the Rust compiler just made it felt like it was going to burn the skin off my lap. And everything ground to a halt. So I was like, okay, I need to get something a bit more powerful than this. Thankfully, a few years have passed and everything's got faster, but that was pretty annoying at the time. And I do worry that stops some people from being able to effectively contribute. I'm very lucky in that I can afford expensive computers, but not everyone can, and I'd really like it to be as accessible as possible, really.
Yeah, true. Okay, I think we have a really great, I think any more kind of topics I can talk about, we're just going to be down like a huge rabbit hole, right? We're nearly approaching kind of the end of our time. I think if there's nothing else that you want to kind of bring up, then I think it's kind of good. What I like to usually ask people is, do you have any kind of tips or tricks that you think beginning Rust developers should know or should look into, or anything like that? And it sounds like you're already kind of talking a little bit, maybe kind of learn more and play more with the borrow checker seems to be a good tip or good way to kind of dig into.
Yeah. I think I've got some ideas. So people often say that the Gleam compiler is surprisingly easy to work in, which I take as a real compliment. And I think the reason for that is that I try and write the perhaps this is not the most tasteful way of describing it, but I try and write the dumbest code I can. I try not to use, if I can do this in a way that's maybe slightly more verbose but doesn't use fancy features, I think that's probably a better way to go up until the point where the verbosity is really causing me a pain in the ass. But it almost always turns out that I never look at it again, or I come back to it and go, oh, it's really simple. That's cool. I know what I'm doing. While if I try to make it a bit more concise and try to be clever with some interesting traits or interesting, interesting ownership features, I sort of regret it. I come back to it and say, oh gosh, what is this? How does this work? Or I've got to change it in a way that I didn't take into account when I was trying to write the trait. This is really quite challenging. So, the more you can do with, the real basics, the boring bits of the language, the better, I think. Don't feel you need to make things clever, because if you make it as clever as you can do it, the next time you come around and you need to be even cleverer, well, then you're stuffed because you've already gone as far as you can. The other thing is probably it's really exciting in Rust to make things really fast and to avoid allocations and super optimize everything. When you're starting, don't bother. Or rather, don't feel you have to. Cloning is fine. Clone with wild abandon while you're getting started, because a program that doesn't run because you can't get it to type check is much slower than a program that runs in a not optimal way. So yeah, just clone. And Rust is so fast, it may still be pretty fast in comparison to well optimized code in a scripting language that you might have used before, like Python or even Gleam.
I think those are great tips. I always hear the second one, and that makes a lot of sense. Even though every time you do .clone, you know what it's doing and you feel bad. But when you like do stuff in Python, like although it's making tons of allocations, like using RSpec in Ruby is like, wow, all the allocations it makes, it's insane. But you never think about it because you're not saying .clone, right? You're just writing code and things are just happening. So it's a much different feeling.
You'd never think about, calling filter on an array in JavaScript. You'd never think about, or map on an array in JavaScript. You'd never think about that. But that's doing a full clone of the entire array, right? Like every single time. You don't even think about it. So yeah, go ahead, clone. Why not?
All right. If nothing else, like I'm really, really fantastic to have you on. I think you said you're working on your tooling and all that. Maybe if you could drop us a line when you have something, and maybe you can talk some more about that, because you just said you do want to get more into the Rust community like me, right? You want to kind of put some stuff out there. I think that'd be great to hear about, like what you're working with it. I know that there's like one other language that's being written with Rust that came up recently, a video game one, something like it's inspired by Lua. I forgot the name now.
Is it Glue?
Maybe it's Glue, yeah. I'm trying to remember now. It's quite interesting. So it's really interesting to see languages being written with Rust and why they do it. Because it's always been C for forever, right? So it's interesting to see, what's going on in that.
Yeah, it's really nice to see Rust muscling in on the old C and C++, I think. I think it's really cool.
Yeah.
Having said that, writing lots of Rust has given me a real sort of appreciation for C++, and I feel like I need to go back and have another go at learning it properly, I think, because it's, lots of interesting things to learn, I think. It'd probably make me a better Rust programmer, knowing a bit more C++.
I always hear that people become better C programmers after playing around with Rust, and I think that makes sense because you start writing your code slightly differently, and yeah, it's whatever. I mean, every language I learn, I always feel it coming back and pushing me in another direction, and sometimes good, sometimes it's bad. But sometimes, like I look at Java code and I look at Python, and I'm like, wait a minute, the guy who wrote this Python code actually was a Java developer, because this doesn't make any sense. Yeah. So I usually see the latter rather than the former, where it's like I'm making progress,
Well, that was my problem with one of the first versions of Gleam. It would just, one of the first Rust versions of Gleam, it would every now and again just have a Stack Overflow. And I could never work out why. And it's because I was writing Rust that looked very much like Erlang. In fact, I almost copied the Erlang version line for line into Rust as the first version. And it turns out if you just do loads of like tail recursive, if you just do loads of tail recursion, it works really well in Erlang. It might not necessarily work in Rust. So I just, I crashed all over the place, which is a bit distressing.
I do wish we had some tail recursion within Rust, but at the same time, they're different languages, right? So you have to go for loops instead.
Yes, exactly. I think when I started Rust, I was like, no, I must write good, pure, functional code, like trying to make it look like Haskell. But these days, I'm like, nah, I just use for loops. For loops are pretty good.
Yeah, I'm not used to loops when I went back to it because I've been avoiding those. Just having because you have pattern matching, right? Which is interesting. And you're kind of like, man, I wish I could do pattern matching at the function head. That is nice.
I think I'm a bit of a, I think I have an unpopular opinion in the Erlang world in that I don't like pattern matching in the function head, because I don't like that there's two ways to write the same thing. Like you could have a function that pattern matches in the function head, or you can have a function that's just got one head and then it has a case expression. And actually, if you look at the compiled Beam bytecode, they are the same thing. Function heads compile into the case expression ones. I'm like, I don't like that we've got two of these things. I think when you've got two ways of doing something, it can be a bit confusing to newbies. I'm not sure if I just have one.
No, I understand. But at the same time, like having one function head with a do at the end of an Elixir, where you have just one line for everything, it's just much easier to read.
It does look so nice, doesn't it? Yeah. So maybe I'm wrong, but this is the hill I'm dying on at the moment. But who knows? It might be a mistake.
Again, thank you so much. It's late over here, and I'm still jealous because you still have sunlight. So it'd be good to catch up again once you add some more stuff, add more tooling and all that. I'd love to hear how it's going. Otherwise, thanks again for coming. Hope to have you again soon.
Yeah, thanks for having me. It's been great fun. It's always nice to nerd out about Rust and Gleam and stuff.